Hello, everybody, and welcome. Today, we're going to be talking about methods and tools for time series data science problems with InfluxDB. My name is Anais Dotis-Georgiou, and I'm a developer advocate at InfluxData. For those of you who don't know what a developer advocate is, a developer advocate is someone who represents the community to the company and the company to the community. So I create blog posts, documentation, give presentations like this, sometimes host meetups, and give talks to help educate the community about InfluxData and how to use it. And then I also bring back feedback from the community and help on forums and Slack channel to answer any questions you have and bring your product feedback back to product so that we can make informed decisions. I encourage you to reach out on LinkedIn and connect with me there if you want, and ask me any questions that you have about time series data or InfluxData. So let's talk about the agenda for today. So we're going to talk about using Flux for data processing and preliminary data analytics, and also about lifecycle management of your time series data. Then we're going to talk about forecasting and anomaly detection with Telegraf, and I'll explain what Telegraf is. It's one of our products. And then I'm going to talk about integrations with other machine learning tools with Jupyter notebooks and Zeppelin notebooks, as well as some of my favorite open source libraries for time series forecasting and anomaly detection. And last but not least, I'll finish off today's presentation discussing some of the customers that use InfluxDB to build out their own machine learning pipelines or offer machine learning solutions to their customers. So before we get into the nitty details about how we can leverage different tools from InfluxDB to create time series machine learning problems and solve them, I want to give a little bit of background. So first of all, what is time series data? Well, time series data is any data that has a timestamp associated with it. So that timestamp could be in hours, minutes, seconds, or even nanoseconds. InfluxDB supports nanoseconds, and the sources are from all over the place. We see time series data being created both in the physical world through sensors, pressure, temperature, humidity, flow rate, concentration, light, etc. But we also see time series data being collected from the virtual world. So people are monitoring networks and infrastructure and application. There's CI/CD pipelines, ML ops, for example. So basically, time series data comes from a variety of different sources. And today we're going to talk about the rise of time series. So what many people found was that conventional databases that were already on the market were just not cutting it for the time series use case, because one thing that makes time series unique is that typically you want to be collecting a really high ingest rate of data, and you're also typically concerned with acting on data in the present time. And so each DB on the market, whether or not it's relational, document, or search, they all excel at their own categories, and you shouldn't put time series data in those types of databases, just like you shouldn't put, relational data in a time series database. But there wasn't a platform that allowed you to manage your life cycle, your data life cycle, your time series data life cycle, and work through all the eccentricities that come with working with time, like truncating time, rounding time, time zones, visualizing time, shifting time, normalizing time, expiring old data automatically as you no longer need it. So essentially, this is why this new category emerged, was because people realized that they needed out-of-the-box solution to address all of those concerns. So now let's talk about InfluxData. So InfluxData is the creator of InfluxDB, and the InfluxDB platform is a time series platform that really contains two pieces. Telegraf, which is the collection agent for metrics and events. It's OSS offering, and it's plugin driven. So there are over 200 input plugins, for example, and a variety of output plugins, processor plugins, aggregator plugins. And so if you have the task of trying to collect data from a source that is time series data that has a timestamp associated with it, and you want to write that data to another source, and you want to take advantage of buffering capabilities and caching capabilities with a lightweight agent, highly recommend checking out Telegraf. Then we have InfluxDB, and InfluxDB is at the core of InfluxData's offerings. So InfluxDB is a purpose-built time series database, but it also has a visualization layer and a query and task engine so that you can not only query your data, but also use Flux, which is a scripting language for InfluxDB, to process your data. So with InfluxDB, you can collect data, you can transform it, you can downsample it, or in other words, make a materialized view of your data and transform that data from a raw high precision format to a low precision aggregate as needed, so that you can, maintain the overall trend of your data without as many points. Because oftentimes, as data gets older, you only need, a high level view of what your data looked like in the time, and you don't need, as many detailed points. And then you can also create triggers and alerts on top of your database, on top of your data as well. There's also a bunch of client libraries that InfluxDB supports, and InfluxDB is also should mention there's an OSS offering as well as a cloud offering with a free tier. I find that a lot of people like to start in the cloud offering with the free tier just to get a feel for it, because they don't have to do any work to play around with it. And then if they like it, then they'll usually switch over to OSS, and then as their needs grow and they decide that maybe they don't want to host it themselves, then maybe they check out InfluxDB Cloud. But essentially the idea here is that we help developers collect time series data from a variety of different sources in the languages of their choice or with Telegraf, depending on your needs, process and visualize that data within InfluxDB and manage the lifecycle of that data, and then either build other applications on top of that, gain infrastructure insights, or even produce IoT actions as a result of the time series data. So now let's talk about Flux. So InfluxDB comes embedded with a functional data scripting language called Flux. And this allows you to build data pipelines to query, analyze, and transform your data. If you take a look at it, that's just a screenshot of what it looks like. It looks kind of JavaScript-esque in its syntax. And in essence, Flux allows you to query for your time series data, manage your time series data lifecycle, alert on your data, analyze, clean, and transform your data. And we'll cover some of the other capabilities and features that Flux has to offer in following sections, as well as some new news about the evolution of InfluxDB and other things to look forward to. So what all can you do with Flux? You can query with it, but you can query other databases as well directly. You can query SQL sources, for example, or CSV, so that you can bring in other types of data ad hoc as needed. So if, for example, let's imagine that we're doing predictive analytics on, some sort of machinery in a factory, and we want to estimate when it will fail. And we do have certain conditions that define, when that piece needs to be replaced. And so let's say we've met those conditions. Well, we could create a task with Flux to query from a SQL database to bring in relational data pertaining to that certain part, so that the person in charge of ordering that component has all the information they need. So for example, maybe you realize that a part is failing, and then part of your alert involves querying a relational database or a SQL database for information like purchase date, warranty information, part ID, etc. And you bring that in at the time of failure, so that when you alert on that failure, you can take action. You can also filter for your data. You can perform aggregations, joins, pivots, unions. So it has kind of like a pandas feel if you're familiar with pandas and Python. You can also analyze your data. You can perform math across measurements, some simple anomaly detection, alert whether or not things exceed thresholds or standard deviations, or even things like median absolute deviation. There's all sorts of fundamental functions for time series analysis, fundamental statistical functions for time series analysis, things like correlation, covariance, standard deviation, mean, just your typical statistical functions. Then there's also functions for downsampling your data. You can write custom functions. You can create conditional logic, perform checks, create alerts and notifications, and write data out to HTTP and MQTT if you need as well. So now let's talk about Telegraf a little bit, because one plugin in particular is a processor plugin, and it's called the execd processor plugin. And this plugin makes Telegraf extensible in any language, and it runs as an external program and pipes metrics into the process's standard in and reads process metrics from its standard out. So with it, we can actually perform some forecasting at the edge, which is what we did in this one project. So we had, for example, another engineer at InfluxData who was monitoring his home brewing setup when he was making his beer. And essentially, he used a segment OCR, or optical character recognition, to read the temperature from his digital thermometer for his wort, or his brewing batch. And his objective was with us to use the execd processor to help him maintain a constant beer temperature so that he could have the optimal conditions for brewing his beer. And specifically, the goal was to forecast the temperature so that if it exceeds a certain limit, then he knows that he needs to add more ice into that bucket there to maintain the proper temperature. And we also wanted to calculate prediction residuals. And that's how we like to find whether or not there was anomalous behavior. So basically, if we forecast a value that's very high and that's different from the current value that we're getting, then we can alert on it. So this is kind of what his data looked like. We see quite a bit of variance. It's not very clean data. It's messy data. It's the real world. It's probably due to bad OCR reads, maybe moments when the thermometer shifted, or he, maybe dumped ice in, who knows. But the point is that looking at this data, it's not really regular. It has a lot of essentially anomalies, or it's pretty hectic. So we needed to use a forecasting method that would be very simple and still yield good results. And we needed one that didn't need a ton of data to train on. We needed to be able to produce data or forecast almost instantaneously, because we're running this at the edge and we want to continuously outputting little batches of forecasted temperature data. So we decided to use double exponential smoothing, or Holt-Winters method. And the reason why it was selected was because it required little data, and it doesn't require that your data exhibit seasonality. It's computationally efficient, and it's an extremely accurate univariate time series forecasting method. So we did that, and we wrote a little Python script that basically would take that temperature data, output a temperature forecast in little micro batches, and this was all done with Telegraf. So the execd processor plugin runs an external program as a separate process and pipes metrics into the process's standard in and reads process metrics from its standard out. And the program must accept Influx line protocol, which is the ingest format for InfluxDB, on standard in, and output metrics in line protocol as well for InfluxDB in the specific case, because we paired this plugin with input and output plugins for InfluxDB. And the job of Telegraf on the output is to convert the metrics from another source and return them to line protocol so that we can actually write them to InfluxDB. And so this plugin kind of sits in the middle of our plugin list. And the program output on standard error is mirrored to the Telegraf log. So this is essentially what the config looks like. It's a single TOML config. We specify configuration for the agent, like the interval that you want to collect data at, how quickly you want to batch your data, or what the batch size looks like, if you want to round your interval, your collection jitter, all these different components to efficiently collect a lot of data with Telegraf. Then we have our input execd plugin, as well as our processor execd plugin. And then we write data to standard out just to make sure that it looks right, and also InfluxDB as well. And we include, authentication tokens from InfluxDB, as well as the URL that InfluxDB is running on. And so, yeah, that's essentially it. We don't really have to go into too much detail, but it just gives you an idea for what running a Telegraf agent looks like. You just need this one config, and then you pass it to Telegraf in a single CLI command, and you are good to go. And this is kind of what the simplest example of an implementation of execd would look like. So this is an example.py script, and all it's doing is reading standard in and printing the metrics as standard out. So you can imagine that instead of this, we would actually have a Python script that took our metrics from standard in, produced the forecasts in batches after collecting them, and then after collecting enough data to create a forecasted batch, and then output that to standard out and Telegraf. And this is what our forecasting py script looks like, but we don't actually need to look at it in detail. So now I wanted to highlight some of the notable integrations that InfluxDB has. Specifically, I want to talk about integrations with Zeppelin and Jupyter notebooks and some of my favorite open source Python libraries. The reason why I'm going to focus on Python, while a lot of machine learning and data science is done in Python and R, I find that more time series specific libraries exist in Python than R, and it's also my favorite way to work with time series data. So, I'm biased, so that's why I'm going to be highlighting them. So this is the Jupyter Notebook's Flux interpreter, which allows you to directly query your InfluxDB instance. So in this example, I just have to pass in the credentials that my InfluxDB instance requires, like the token and the organization and the URL. And then I can directly use Flux to query and immediately return back a pandas data frame so that I can just apply, any of the methods or libraries that I would want to use after that. So that just makes, all of that process much simpler. And then the next thing I wanted to mention is the Zeppelin interpreter. So if you're not familiar, Zeppelin is a notebook similar to Jupyter Notebook, and it has a built-in Apache Spark integration. So if you have a large amounts of data and you need to parallelize it, you can use Zeppelin as well with your data stored with InfluxDB. And here's an example where you can just query it directly with the interpreter as well, which is in the top line of code. And you don't have to instantiate an object and import the client library and do all the boilerplate that you would need to do normally. Zeppelin is great too, just because you can parallelize your workflow and your data processing for big data use cases, especially if you're using Spark. So last but not least, I wanted to take a moment to talk about some of my favorite Python libraries. So the first one I wanted to introduce you to is the ADTK library, and that stands for Anomaly Detection Toolkit. And this is a Python package for unsupervised rule-based time series anomaly detection. So essentially, the way that it works is that you can choose and combine different detection algorithms or detectors and different feature engineering methods and ensemble methods to build your own effective anomaly detection model. So this is especially useful for situations where you understand, or the developers understand, what the data should look like and have an intuitive feel for the conditions around what an anomaly might be. And so you can, build this rule-based system that can be quite powerful. The second tool is Facebook Prophet. So Prophet is a procedure for forecasting time series data, and it's based on an additive model similar to Holt-Winters, essentially. But some of its noteworthy elements is that Prophet was designed to make forecasting easy for people who don't already have experience or training with time series data. Because time series data is very unique, statistically speaking. It's actually, it's not independent data, it's dependent. And that produces all sorts of weird statistical phenomenon that, you might not have specific training in. So Prophet requires minimal data preparation to work, and you don't need to normalize your data. You don't need to do any sort of interpolation to normalize your data. You don't need to, remove seasonality or add seasonality. And so you can also intuitively add a lot of information that you want about your data. Like you can add, seasonal holidays to it pretty easily. You can specify whether or not your data will converge to certain limits. Anyways, it tries to make forecasting really simple. And then there's neural profit. So if you do have experience with time series, then you can use neural profit, which is a neural network based time series model. And it's an autoregressive neural network. And it especially shines for data that is sparse and multidimensional. So if you have a bunch of different time series and they're not always reporting and they, help paint the image of a bigger system, then that's a good one to use. And the last tool is CATS. And this is an anomaly. This is a time series analysis library, for forecasting anomaly and anomaly detection and data preparation. So it's kind of your one-stop shop, and it goes pretty deep and comprehensively into generic time series analysis and classical and advanced techniques for modeling and predicting time series data. So yeah, those are what I recommend. And now, without further ado, I wanted to highlight some of our customers. So we have a lot of customers in the IoT space, including, Tesla, Bbox, which I'll talk a little bit about later, WakeConnect, et cetera. You see the list there. And then in software too, we have quite a few impressive names as well. But I wanted to take a moment to specify and focus on some of our customers, that are using InfluxDB for data science problems. So Izuko uses InfluxDB to power their product called UpalGo. And so this UpalGo is their time series management platform. So Izuko considered multiple time series databases, but ultimately picked InfluxDB because it met all of their time series data requirements. They liked that InfluxDB was purpose-built for time series data and that it could handle the really high ingest rate that they required. And additionally, that InfluxDB supports nanosecond precision. And what Izuko found was that their team could really focus on providing clients with the best machine learning models and anomaly detection solutions on top of InfluxDB. And they use InfluxDB as their data lake and then pull data out to their data warehouse to execute further analysis, which is what we recommend as well. So that's a really cool use case. And another one of my favorites is Bbox. So Bbox is a really cool company that provides energy to remote communities who don't have any with solar panels. And they have the problem or requirement of needing to monitor solar panels and the overall energy usage in all these communities. And they monitor over 85,000 solar rooftop units and provide insights to customer usage patterns and anomaly detection. And they use InfluxDB to do all that monitoring. And so that's another really cool use case of someone who is using InfluxDB for some data analysis. And before I go, I wanted to introduce the new InfluxDB storage engine. This is built on Rust, Apache Arrow, Parquet, and Data Fusion. Rust helps provide fine-grained memory control. Arrow is a framework for defining in-memory columnar data. Parquet, if you're not familiar with it already, it's a column-oriented durable file format that is way more efficient than CSV. And Data Fusion is a query execution framework for high-performant data analytics. And so with this revamp of the storage engine that will be available in InfluxDB Cloud starting January 31st in AWS on EU Central and US West, I believe, then you can not only query data with Flux, but you can also query data with SQL. So if you don't want to learn a new query language, you don't have to. So that's one really exciting thing about it. But what's even more exciting about it is because it's going to be built on the Apache ecosystem, it'll have interoperability with a bunch of machine learning tools. So Parquet specifically You'll be able to eventually query Parquet files directly from InfluxDB. And Parquet offers interoperability with almost all modern machine learning analytics tools. Whether or not you're using Spark or Pandas, you can convert, Parquet files directly to data frames and then do whatever you want with them there. They also, tools like Tableau, Power BI, Athena, Snowflakes, Databricks, they also offer Parquet support. So InfluxDB will have that out of the box as well. And then Data Fusion, it supports both a SQL and a data frame API. So we'll first support SQL and then hopefully eventually also support Pandas directly. So you could query with both and just open up the world to you there. And so that's really exciting. And if you want to get started with the new storage engine, I highly recommend that you join the community Slack channel and look for the InfluxDB_IOX channel. We just call it IOX. It's the same thing as the new engine, just because it's built on Rust, and the chemical symbol for Rust is iron oxide. So it's just kind of fun play on words. And last but not least, today I was brought to you by InfluxDB University. So InfluxDB University is a platform where you can get free courses on all things InfluxDB, all of our platform. And so if you want to learn more about InfluxDB, that's a great place to start. And you also receive badges that you can display on your LinkedIn about the skills that you've learned. So highly recommend checking that out as a resource. If you want to try InfluxDB out for yourself, I recommend going to our website. Otherwise, if you want to see some of the projects that the developer advocate team has done with InfluxDB, check out the Influx community repo. It contains a bunch of example code for a bunch of different use cases for InfluxDB, and maybe it could get you inspired. And last but not least, here are some additional resources. You can get started with InfluxDB Cloud, get that free tier going and give it a try. I encourage you to join the forums, the Slack, Reddit as well. Check out our Influx community organization, like I mentioned before. Docs, blogs, InfluxDB University, all these are great resources to get you started on your journey with InfluxDB. Thank you so much. Bye.